We are now going to use the Newton-Rhapson method, or the Newton's method, as it is always also called, to work out an approximated value for the root alpha of this function. Okay, but the first question relating to finding the root is to determine whether the root lies between 1 and 1.1. Now, if we take this is just an example graph. This graph doesn't represent 2 cos x minus x squared. But if you take this graph, and let's say that's the root r, okay? And we take a value to the left of r, let's say in this case it's 1, and if you take the x value 1, you'll get a corresponding y value that is positive. There, let's say you take 1.1 as the x value, you'll get a corresponding negative y value. And you can see from the graph, if you have a positive y value for an x value and a negative y value for a specific x value, then you know that the root will lie between those two x values. So that's why we do this question 1, is to determine if the root lies between 1 and 1.1, and then we can take a good guess of where the root might be, and that is what you then use, the first guess, to determine your approximated value of the root. Okay, so let's see. Show that the root lies between 1 and 1.1. So what you do is first you put in 1 into your function. So it's 2 cos 1 minus 1 squared. And remember, we are working now with radians, so you must put your calculator on the r, on the radians, and the value you get when you place in 1 there is 0.08. So we can see this is positive, okay, clearly. Then you put in and 1.1, you substitute in 1.1 into the x's place, so then it's 2 cos 1.1 or 1,1 minus 1,1 squared, and you get a negative number. So that definitely shows us that the root lies between x1, oh, this is a negative number obviously, and that definitely shows us then that the root lies between 1 and 1.1. Okay, so that one we have figured out. Now they say use 1.05 as the first value, as your first guess. Now they say we must use 1.05, and we will do it, but if there's another question and they didn't give you the guess as 1.05, you can choose any number between 1 and 1.1 as your first guess, and in this method, okay, to determine the approximated value of the root alpha. Now let's do the second question now. Okay, so we know our first guess, or let me rather use a green. Our first guess will be x1 is equal to 1.05. And remember the formula for the Newton-Rhapson method is, the general formula is xn plus 1. You use the previous value, so to get the next value, you use the previous value, and you substituted the previous value, the xn, into the function, and you put it also into the derivative function. Okay, now we are going to need to get x2. This is what we are moving towards, and just to put it also in a formula, x2, this is the next value you use by getting the previous value, which is the x1, and you subtract the fx1, so the x1 substituted into the function f, divided by the derivative at x1. So you'll see then we'll need to get the derivative. We know that what is fx? We know fx is equal to 2 cos x minus x squared. So we'll need to get the derivative because we need the derivative in the Newton-Rhapson formula to work out the x2 and the other approximations. Okay, so now the derivative of cos x is just minus or negative sine x. So you'll say it's negative 2 sine x, and to get the derivative of x squared is just 2x. And into these x values you'll place in all your x values. Okay, so to work out x2, I'm going to work with a white from now on. To get the x2, you will need to get the x1, okay, which we know is going to be 1.05, and you're going to put the 1.05 into the function f and into the derivative 1.05. Okay, so let's just work from here, just give us some more space. So you put in 1.05, and then you'll put into the function, into the x value, 1.05. so you'll have 2 cos 1.05 minus 1.05 squared divided by, now you put in 1.05 into the derivative, into this one you put 1.05, so into that one you'll put now 1.05, and into that x there. So you will say it's negative 2 sine 1.05 minus 2 times 1.05, and the answer you will get is then for x2 1 comma or 1.022004. Okay, now to get x3, what do we do? Well, to get the next number, you must take the previous number. This is the x2 we got there. You place it in there, minus the f at x2 and the derivative at x2. So you just put in x2 into all the x values of your derivative and of your function there. That's all you do. And if you substitute it, you will see that you will get a value of 1,022,1689. Okay, so now we see from x2 to x3, our first three numbers after the decimal, or the decimal numbers, are the same, but our question said our first 5 numbers must be the same. So we need to continue with this approximation, and you'll see when you use x3 then to work out x4, you will get 1,021,689. Now we can see, oh sorry, did I say 0,22 at x3? Now you'll get 021, that one shouldn't be there, sorry, 1.021689, and now you will see that the first 5 decimal numbers are the same, and you can stop there. So the root x approximation is going to be 1,021,896. Hey, sorry about that. 6. Let's rewrite that, 1,021,689, because that's the first 5 decimal numbers. And just to go back to x2 and x3, it's the first 2 decimal numbers that are the same, so we needed to continue to the x4, and from the x3 to the x4 we achieved what we wanted, the first 5 decimal numbers that are the same, and that's then your approximation.